Milk, an important food for the health of the nation. Pasteurized milk, a safe food, trusted by millions of people and important in every diet, of special importance to children and invalids. For all these people, pasteurization is a guarantee of safety. There is no such thing as partly safe milk, for milk is either pasteurized or it isn't. Pasteurization is a scientific job, a responsible job, and extends directly to men people seldom see or know, men to whom they entrust their health, milk plant operators. Perhaps you work in a small plant like this. The building is well built and kept in good repair. Besides a cold room and utility rooms, this plant has 3 rooms for handling milk and milk containers. The receiving room, the pasteurization room, the bottle washing room. These rooms contain equipment especially designed to protect the milk from contamination. The milk flows from the receiving vat to the pasteurizer. After pasteurization, it goes through the pump, then spreads over the surface of the cooler to the filling machine. The most important factor in producing pasteurized milk is the care with which you handle it, the methods you use. The milk is delivered to the receiving room. Use of this room helps keep flies out of the rest of the plant. Always keep the cover on the receiving vat, except when the vat is in use. Remember, milk is food. Protect it. Your first responsibility is to make sure that all of the milk you receive is of high quality. A single can of poor milk may ruin the whole batch. An experienced operator can usually detect such milk by its odor. If you suspect that the milk is too warm, check it to be sure. Stir the milk to get an accurate temperature reading. "79 degrees, and off odor, too." Rinse the thermometer and the stirring rod and return them to the sterilizing solution. This rejection slip explains to the farmer the reason why his milk is being returned. When all the cans are emptied, replace the vat cover and turn on the milk pump. This forces the milk through sanitary milk piping to the pasteurization vat. Be sure the inlet valve is open. Turn on the agitator and the water jacket circulator pump. Always keep the vat cover closed during operation. This keeps the heat in and prevents dirt from getting into the milk. This pasteurization vat has 3 thermometers. On the left, an indicating thermometer, an airspace thermometer, and a recording thermometer and its chart. The airspace heater assembly is made up of a steam strainer, a control valve, a condensation leg with steam trap, an auxiliary water trap, and a steam gauge. This unit provides a flow of clean, dry steam to the inside of the pasteurizer. The agitator motor and shaft, as well as all other instruments and pipes, are connected to the vat cover in such a way that no dirt can get through the openings. Good equipment, well cared for, helps you protect the milk from contamination. Let's see how this pasteurization vat operates. The space between the insulated outer wall and the inner wall forms a water jacket. The water is heated by steam in a mixing valve just before it enters the vat. The water jacket is filled up to the overflow pipe. The milk enters the vat through this inlet pipe. The vat is filled with milk to a level just below the level of the water in the jacket. This ensures that all of the milk will be heated. The indicating thermometer bulb reaches almost to the bottom of the vat. This thermometer is used to determine the exact temperature of the milk. It must be accurate. The recording thermometer provides a permanent record of the temperature of the milk. Its bulb also extends well down into the vat. The agitator stirs the milk so that it is heated evenly, and all of the bacteria are exposed to the pasteurizing temperature. Through this airspace heater, clean, dry steam is forced into the space between the top of the milk and the cover of the vat. This makes sure that any foam or drops of milk which have splashed onto the cover or sides of the vat will also be heated to pasteurization temperature. Another thermometer, called the airspace thermometer, determines the temperature of this airspace. The bulb of this thermometer must not touch the milk. This outlet valve is placed on the side of the vat so close that the stirring action of the agitator reaches even the milk in the outlet pocket. The outlet valve is a leak protector type. If the valve is loose, worn, or scored, unpasteurized milk may seep between the plug and the inner wall of the valve. To prevent this unpasteurized milk from getting into the outlet pipe, grooves on the inside wall of the valve catch the milk and bring it out through the bottom of the valve. This type of valve prevents raw or partially pasteurized milk from contaminating the outlet pipeline when the valve is closed. As the milk runs into the pasteurizer, turn on the steam to the jacket, which is already full of water, and then turn on the airspace heater. This should be on during the entire filling time to keep the air above the milk in the vat at least 5 degrees above the milk temperature. When the vat is full of milk, turn off the inlet valve. This valve, like the outlet valve, is a leak protector type. It prevents raw milk from leaking into the vat during pasteurization. When the indicating thermometer shows that the milk has almost reached pasteurization temperature, turn off the steam to the jacket to prevent the milk from becoming overheated. Pasteurization begins when the temperature of the milk reaches 143 degrees, not 1 second before. This is the lowest temperature which, if held for 30 minutes, will kill all of the disease germs which might be in the milk. The steam supply to the airspace heater is adjusted so that the airspace temperature is at least 148 degrees during the entire pasteurization holding time. This is important because tests have shown that 148 degrees is the lowest airspace temperature which will heat all foam and drops of milk on the cover and sides of the vat to at least 143 degrees. When the milk reaches pasteurization temperature, turn off the water jacket circulating pump, but leave the agitator on during the entire pasteurization holding time. Remember that the indicating thermometer gives you the accurate milk temperature, but to be sure the recording thermometer is also accurate, compare it with the indicating thermometer once during pasteurization, usually after the milk has been at pasteurizing temperature for about 10 minutes. Write the indicating thermometer temperature on the recording chart as a permanent record. If there is a difference between the two readings, the recording thermometer should be adjusted before it is used again. Other important facts are entered on the chart. The airspace temperature is sometimes added. If anything unusual happens, such as a power failure, make a note of it on the back of the chart. As pasteurization continues, frequently check the indicating thermometer and the airspace thermometer. If they show the temperatures of the milk or airspace are too low or too high, adjust the steam valves to maintain correct temperatures. Pasteurization requires time as well as temperature. The milk has been held for a full 30 minutes at 143 degrees or more. It is now pasteurized. All disease bacteria have been killed. It is safe milk. From now on, great care must be taken to prevent recontamination. Turn off the steam to the jacket and to the airspace heater. Turn on the cold water to the jacket to start cooling the milk. The cold water enters here, mixes with the water in the jacket, and runs out through this overflow pipe. Turn on the water jacket circulating pump and leave the agitator running. The recording thermometer chart records the prompt cooling of the milk in the vat. At the end of the 30-minute holding time, the pen arm drops as the temperature of the milk is lowered by the cold water in the jacket. In some plants, the milk is not cooled in the vat. In such cases, the recording thermometer continues to show the milk at pasteurizing temperature during the additional time it takes to empty the vat and expose the thermometer bulb. And the chart must show 30 minutes holding time plus the emptying time. But regardless of the cooling method used, the milk must be kept in the vat a full 30 minutes at least 143 degrees before the outlet valve is opened. When the milk has been cooled to about 120 degrees, about as low as cold water will cool it, open the outlet valve on the pasteurizer, adjust the valve in the line, and turn on the pump. The milk flows from the pasteurization vat to the pump, through a flow control valve, and onto the cooler. The cooler is always kept covered while in use. These covers fit tightly at the sides. They overlap at the top and cover the collection trough at the bottom. The covers prevent contamination of the pasteurized milk by accidental coughing, sneezing, or flies and dust. This cooler is built in two separate sections. Cold water circulates through the top section and brine through the bottom. The ends of the coils, called headers, are specially constructed so that moisture condensing on their cold surfaces cannot drip into the milk. The space between the headers is well over 1/4 inch to permit cleaning. The bottom of the header is designed so that moisture will not drip into the milk in the collection trough. As the milk flows in a thin film over the cooler, it is chilled to well below 50 degrees. Prompt cooling is important because it prevents the growth of bacteria. Always keep the cooler covered while milk is being cooled. The milk flows from the cooler to the bottle filler. The supply pipe has a shield or apron to prevent moisture on the cold pipe from running down into the milk in the bowl of the filler. Always keep the sight hole covered while the filler is in use. The filler valves are also protected by diverting aprons to prevent condensation from falling into the milk bottles. Be sure your hands are clean before you handle bottles and caps. This wash basin is located conveniently in the pasteurization room and has hot and cold water, soap, and sanitary towels. Bottle caps are stored in a clean, dry cabinet which protects them from flies and dust. In loading the capper, trip it to discard the first cap. This cap has been exposed and may not be perfectly clean. Next, load the hooding machine. Now turn on the filling and hooding machine switches and begin bottling. Clean bottles are kept inverted until they are used to prevent dirt from falling into them. Never touch the lip or inside of clean bottles with your fingers. Always give the bottles a quick inspection for cracks, chips, or dirt. A mechanical capper makes it unnecessary to handle the caps by hand. Hoods like these are one way of protecting the pouring lip of the bottle from dirt. Inspect each bottle to be sure it is properly filled, capped, and that the bottle is not chipped or dirty. Reject bottles that are not completely filled or are imperfectly capped. Since you always contaminate the bottles when you remove the cap, pour the milk into a can for reprocessing. Use of a dolly keeps the cases off the floor, and you can wheel the full cases directly to the cold room without any lifting. The temperature of the milk must not be allowed to rise above 50 degrees at any time after pasteurization if the growth of bacteria is to be prevented. Except in very cold weather, ice the milk before delivering it to the customer. This milk has been pasteurized, cooled, bottled, and capped. You have taken great care to protect it against every possibility of contamination. You have the satisfaction of knowing that you did your job well. You can send this milk from your plant with the knowledge that it is safe milk.